Hello all and welcome to Draw a Picture video. I remember when I was in grad school one time, one of my professors told me that if I wasn't able to draw a picture of what was going on, I truly didn't understand that. And I think that being able to draw a picture based on some story problems is a really important skill to have. So we're just going to start in on this first problem. So Jamie Lynn has planted a lovely rectangular rose garden that is 30 feet by 48 feet. She wants a sidewalk to go all the way around the outside that is 5 feet wide. What's the area of the sidewalk? So reading this, I'm trying to understand the question, and I know they're getting at what is the area of the sidewalk. So we want to know the area of the sidewalk. Now, as soon as I see the word rectangular, I know that I'm going to draw a rectangle. So here, I'm going to draw this first little rectangle right here. And we know it's 30 by 48. So I'll say this side's 30 feet, and this side is 48 feet. Okay, so if we want to know the area of this interior piece right here, like this piece right here, we could determine what that's going to be just by multiplying the length times the width. Now, 30 times 48 is going to be 1,440 feet squared. Okay, now we're putting a sidewalk all the way around it. So what we're doing essentially is we're putting another rectangle around this guy where this dimension right here is 5 feet, this dimension here is 5 feet, this dimension here is 5 feet, and that dimension there is 5 feet. So the way that I'm going to come up with the area of this red piece right here is calculate the total area of this external rectangle, that is this rectangle here, find out what this area is, and then I'm going to subtract out this area that we already found. So the total area minus that little interior piece is going to give us that exterior. So if we want to know the dimensions of this bigger rectangle, the real question is, what is this length right here? Okay. Well, we know the interior rectangle is 48, and then we have 5 feet on this side, 5 feet on this side, so that total area is 58 feet. Similarly, if we know this interior's height is 30 feet, and this is 5 right here, and this is 5 right here, it's going to be 10 more than 30, so that's 40 feet. So knowing that area's length times width, the area of the total large rectangle, 40 by 58, is going to be 2,320 feet squared. So this is the larger rectangle right here. This is the interior rectangle right there. To find that red area, we're going to subtract our 1440 from our 2320. And when we do that, and I'm just using my calculator to do this, this gives a total of 880 feet squared. So this right here is the area of that sidewalk right there. Alright, so and this is kind of a consistent thing that we could do. If we want to find the area of an exterior piece, we can find the total area, and we can always subtract the area off of like an interior piece, and that's going to be really productive there. Okay, so here, question number 2, we have 9 people at a cookie exchange. Each bought a dozen cookies. Each brought a dozen cookies for every other person. How many cookies were brought to the exchange? So the way I'm going to do this is I'm going to draw a little picture of what I think 9 people look. And clearly 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we have 9 people, and clearly this is a view from above them, so we can see their heads. Now, we have 9 people. Now, if we want to think how many cookies, or how many dozen cookies the first person brought, they brought 1 dozen for them, a 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 dozen for them. So each of these 9 people, so there's 9 people, brought cookies for 1, 2, 3, 4, 5, 6, 7, 8 people, and they brought a dozen cookies for each of those people. So we have the total number of people times the number of people they're giving a dozen cookies to times the number of cookies in a dozen. This is going to give us a grand total of 880 264 cookies. We always want to give our label of cookies here. So that's how many cookies were brought to the exchange. Probably enough to, that's a lot of cookies. That's a lot of cookies. So that's how that goes. And there's a couple other pictures that you could draw for this one, but I think that this is the most intuitive one, where you're drawing 9 people and then determining, you know, who is each person bringing. They're not bringing a dozen for themselves, so that we're working like that. Okay. So, number 3 here. The houses on a street are numbered 1, 2, 3 on one side of the street, and then the numbers continue consecutively on the other side of the street and work their way back to the opposite of number 1. Okay, so let me think about this really quickly. So what we're saying is this is going to be house. This will be the north side of the street. That'll be south side down here. So that'd be house 1. That'd be house 2, 3, and then it keeps going. And they say if house number 12 is on the opposite side from number 29, so we know 12's over here. 29 is going to be across from that. Okay. So the question is, how many houses are there on each side of the street? So each side of the street, we want to know that. So the way that I'm going to go about doing this, notice I've drawn the picture where I have the street running right here. I know the number 1, 2, 3, 12, and then they continue down to however many there is here. And then whatever number this is, the next one continues on the other side, and then we're going all the way down here. Is we can think about how many numbers are there before the number 12. That is, how many houses are on this side of that street. Now, if we know how many houses there are over here, that's going to tell us the exact number of houses over here as well, since for each street there's kind of a mirror image across from it. So there's 11 numbers between 1 and 12, so there's going to be 11 more houses on this side. 11 plus 29 is going to give us 40 houses. If there's 40 total houses, we know there's 20 houses on each side of the street. Yeah, I'm sorry, my stylus isn't quite fine enough to capture all of this in the space given right there, but excuse me. But that's kind of the general idea, is how someone might do this as well. Okay. So we got a couple more problems here. We'll just go ahead and do those, and once we do the draw picture, put this up, and then we'll move on to the next one. So, here, if we have Gavin was told not to run, but he did anyways, and I think the context here is there's a baseball diamond, if I remember this correctly, because it says he took 18 steps from second base, got caught in a rundown, took 7 steps back, 3 steps forward, 5 steps back, 11 steps forward, 4 steps back, and was tagged out halfway between second and third base. So we know wherever he is tagged out is halfway between second and third. I guess this would be second base, and this right here would be third. Okay? So, at any rate, we know that he's going to be going there, going back, going there, going back, that sort of thing, and ending up halfway there. So, for each step he takes towards the base, we're going to add those numbers. For each step he goes back, we're going to subtract. So, if he takes 18 steps from second base, then he gets caught in a pickle. Took 7 steps back, so we subtract 7. 3 steps forward, so we're adding 3. 5 steps backwards, so we're subtracting 5. 11 steps forward, so we're adding 11. And 4 steps back, subtracting 4. Then he was tagged out halfway. So this is going to give us the distance halfway between second and third. And so, go ahead and use my calculator for this. Minus 7 plus 3, minus 5 plus 11, minus 4. That means that there are 16 steps to get halfway between the bases. The question's asking, how many steps is it from second to third? Well, if 16 steps is halfway, multiply that by 2, and we get there are 32 steps between second and third base. Yeah, so hopefully that made sense to you right there as well. Now, for the last one here, we have a little question about a frog. Now, the frog is at the bottom of a 9-meter well. So, even before I read the rest of the actual question, I'm going to draw a 9-meter well. This is what a well. I guess the ground would be up here. And we know this is 9 meters. That is that distance right there. Okay. So we have a little frog. I'm not going to draw a frog. I'll draw a little circle right there. Excuse me. 9-meter well. So each day he climbs 3 meters up. In each night he slides 1 meter down. So the first day, going to go up 3. But that night he's going to go down 1. Okay, so day 1, day 2, I'm just going to make a little table here. Day 3, day 4, etc. We can track how far he's gone. So went up 3, went down 1, total gain is 2 meters. Okay, so the next day the frog goes up 3 meters, and then that night it's going to slide down 1. So at the end of that day, we're at 4 meters. Okay, so the next day, frog goes up 3 meters, so 4 plus 3 is 7, getting us up to that 7 mark, but that night the frog slides down to 6 meters. I'll label our meters here. The fourth day, the frog's at 6 meters, climbs 3 meters out, and is gone. So it is the 4th day. So the 4th day, the frog will escape. So feel free to watch those again. If you have questions about any of the techniques that I used here, please let me know via email. And yeah, next time I will see you for finding a pattern.